because here is knowledge. Capitalism, and the end of it will be the next topic, so the next conference.
The end of the exploitation of knowledge, academic knowledge, any kind of knowledge by the capitalists.
There was also a book in the capitalism survey. Capitalista, quanto del capitalismo. Okay, are we ready to start, perhaps? And there's still a lot of people over there. Well, I think I've done as much running up as I can. Well, good then. I think we can start. So, Nickles is going to talk to us about heuristic appraisal at the frontier of research. It's a very important topic because it relates to research as well as being theoretically interesting. So we look forward to this.
Let me add my warm thanks to Miliano, to La Sapienza for the support. And I gather some honey from you, Lorenzo. Is that read correctly?
Yes, they are funds shared with the other universities in Italy. I'm just the coordinator.
It's useful to know the core.
Yes. Also, my email address here is here. I invite anyone who wants to write, raise objections. I work in relative isolation out in the Wild West, in Nevada, and Maria Elena Cipolloni already has written me 2 or 3 months ago with some very good questions. I hadn't been thinking about these things for some time because of other deadlines, and so she helped me get my head back into this topic. So I'd be glad to hear from you. I am interested in applying some admittedly controversial theses in a way that I hope I can make halfway coherent to address practical problems. Grant writing, problem choice, but also the decisions that people on grants committees and various administrators and so forth have to make. So here is a kind of preamble. The central problem of epistemology I'll take from Popper, the problem of the growth of knowledge. I think that's basically correct. Innovation drives science, scientific change, as it does capitalist economic systems. And I think we poorly understand the origin and creation of wealth, what we might call wealth, in both. We increasingly recognize that they are both complex adaptive systems with internal states and a nonlinear internal dynamics. Can everyone hear okay? I send to a broadcast fairly loudly. Okay. Here's the kind of a response to Lorenzo from the last session. We now recognize, a century and a half after Marx, how robust both the sciences and capitalist systems are, in that not only can they respond to external shocks resiliently, but they are self-undermining from within in complex ways, and yet they just keep going, reinventing themselves in a very interesting way. So I think the problem of robustness is another issue here. So in short, we believe most systems. I don't mean to convince you to capitalism here, but in terms of economic stimulation and so forth, I think there's a little question that both systems are highly productive, but we don't understand fully at least how or why. just as an example, as you know, political conservatism is a problem in lots of places, certainly in the United States, and I am always amused, at least from my point of view, conservatives adopt a kind of laissez-faire view toward the economy, keep government out and so forth. But when it comes to science and so forth, they adopt a kind of top-down intelligent design model that the government or corporations or whatever can just sort of order people, apply the scientific method, to generate the results we need. Whereas I see the origin of innovation as basically the same in both places. I think there's also some truth in the claim that efforts to improve the performance of both run the danger of bad epistemological models, and that's where the philosophy in a broad sense will come in and lead to bad policy that often hurts more than it helps. So let me just kind of go over the somewhat complicated question structure here. It's not as complicated as it looks. My meta question, one motivating question as I get older, since I'm a representative of the old crowd here, is what have I done with my life, and did it make a difference to anything? And increasingly we ask, what difference does philosophy of science make? I grew up as a grad student in the 60s and then on into the 70s when philosophy of science was a very hot topic. It was the battle of the big systems, and Popper, Lakatos, young Kuhn, logical empiricists, Schulman, lots of other people involved there as well. And at the time it seemed like philosophy of science was as important as any field there was. Lots of people were paying attention to it. These days it doesn't seem so. The scientists don't pay much attention to it, except in specialist fields. Philosophy of biology has really taken off, and several philosophers there have sufficient biological knowledge. They actually engage in research and make sincere, genuine contributions to those fields. Similarly, increasingly with philosophy of cognitive science and so forth. But here we're talking no longer about general models of scientific change, general philosophy of science, but sort of specialized sorts of inquiry. So, so my meta question: what difference can we in science studies? Some of you know, I'm a historically oriented philosopher, but I'm certainly willing to attend to what the sociologists and others are saying as well. What difference can we in science studies make? Do we just end up talking to ourselves? And my quick answer for the difference is that we can provide improved models for how science works, do our bit. We're not alone in this, and try to demonstrate the relevance to policy. I'm going to argue that at a policy level, there's a degree of generality that is still appropriate that philosophers can contribute to without being specialists in particular areas. So, overall question, how can we increase the pace of innovative scientific research, especially so-called transformative research? What methodological or policy steps can we take, given that most such steps are going to limit the laissez-faire aspect of research, at least insofar as we intervene in certain ways, there are certain restrictions going on. My answer, my solution will be largely negative in thrust, but there will be also a positive dimension to it at the end. But I'm mainly interested in decision-making at frontiers of research in terms of judgments of fertility or promise. So sub-question one would be, well, how do scientists and their support networks make fertility decisions at frontiers? And my label, it's a catch-all label, which needs a lot of filling out. I've done a little bit of filling out in the past, intermittently, but it needs a lot more work. I call it a heuristic appraisal, a term, I think it was Ernan and Mullen who first introduced that term. And on the negative side, by not applying strict confirmational appraisal too quickly. I will talk about some experiences on grants committees and so forth in the near future about this. So giving more scope to heuristic appraisal, more scope to future promise, a little bit less to quick chops of proposals that look interesting because they somehow depart from current understandings. So sub-question 2, then, which factors stimulate or hinder such frontier opportunities? There are a lot of them, and some of them are what philosophers have traditionally ignored as external factors. I want to argue that giving more attention to heuristic appraisal considerations actually shifts things so that some factors that previously were regarded as external are completely relevant in the longer run, a longer-term accounting system to the growth of knowledge, and hence our epistemic relevance. Sub-question 3, what is transformative research? Quick answer, it's fairly research at a fairly wild research frontier. I'm going to largely ignore the idea that we can decide on where a scientific revolution of a Kuhnian sort at least can happen and try to fund that. I think revolutions are just too unpredictable, part for the heavy nonlinear waves and so forth that came up in the last discussion. But at least in the United States, the funding agencies like NSF, NIH, and so forth are using this transformational or transformative criterion for evaluating proposals. They clearly don't mean foment a radical revolution, but they mean do something beyond just normal scientific research. So I'm going to focus on that transformative to the middle range in that, say, taking a phrase from Robert Merton. Well, there are many different kinds and degrees of it. I indicated something about degrees. Kinds gets us back to the possible external factors a bit. There are many different places where we can make changes that will facilitate, I think, fertility of this sort. I'll come back to those in a moment. Well, then, sub-question 4, obviously, what is heuristic appraisal versus what I call confirmatory appraisal? For those who happen to read anything in the past, I used to call this epistemic appraisal, but I'm broadening the concept of epistemic, so I don't want to prejudge the issue by using that term. I might mention Thomas Sturm is here. We were both participants in a session in Berlin. When was that, Thomas? A couple of them actually. Yeah, something about 10 years ago or so. Re-examining the discovery justification distinction and its use. And so I thank Thomas for helping to trigger my interest in some of these ideas. A main difference, I talked about this in the past, and in some cases I think I was wrong, but in others I think I got something right. The main difference I will emphasize today is heuristic appraisal has a modal difference from what I'm calling confirmatory appraisal. Confirmatory appraisal was sort of what philosophers would call confirmation theory, testing theories against a data record, predicting a record of success or failure. So that has to do with you might say actual accomplishments, or at least judged accomplishments by the community of past success, past failure. Whereas heuristic appraisal has to do with future promise, with what's plausible, what's I think in more extreme cases even possible. You go beyond plausibility, I think in some cases to possible. In the written draft, which has lots of rough spots in it, I recite a little possibly apocryphal story about Niels Bohr, the young physicist who lives in Copenhagen, and after his talk, Bohr goes for his usual walk with these people and says, I think your ideas are crazy. The trouble is they're not crazy enough. So we got ourselves in a pickle here. We need something really, really different to get out of this. I will not be going that far in my talk today. Okay, Hans-Jürg Freinberger, I've got a passage here somewhere, nicely conveys, I think, the flavor of research at the frontier in his toward a history of epistemic things. If my new eyes and glasses will work here. The experimental scientist deals with systems of experiments that usually are not well defined and do not provide clear answers. Experimental systems are to be seen as the smallest integral working units of research. As such, they are systems of manipulation designed to give unknown answers to questions that the experimenters themselves are not yet able clearly to ask. Such setups are, as Jacob once put it, machines for making the future. They are not simply experimental devices that generate answers. Experimental systems are vehicles for materializing questions. Experimental systems, together with the scientific objects wrapped up in them, are inherently open, if bottlenecked arrangements. Their movement is such that it cannot be predicted if they are to retain their character as research devices. Epistemic things, let alone their eventual transformation into technical objects, and vice versa, usually cannot be anticipated when an experimental arrangement is taking shape. But once a surprising result has emerged, has proved to be more than of ephemeral character, and has been sufficiently stabilized, it becomes more and more difficult, even for the participants, to avoid the illusion that it is the inevitable product of a logical inquiry or a teleology of the experimental process. So that openness, to unpredictable openness. I'll mention good old Donald Rumsfeld, not one of my favorite characters of all time by far, but he said in a famous press conference, notoriously, there are known knowns, there are known unknowns, and then there are unknown unknowns. And people thought he's crazy, you know, but of course he's absolutely right. I mean, I'm adapting his statement. He was talking about that stupid Iraq war, but I'm adapting it to frontier research. And there are unknown unknowns. It's a situation of decision-making under uncertainty. That's the point. Other people have chimed in and pointed out that there are various other possibilities that need to be taken into account. There are unknown knowns and so forth of various kinds. And I will also mention Kyle Stanford, The Problem of Unconceived and Other Conceived Alternatives. A really provocative book, I think, that he wrote recently, in which he is basically highly critical of Bayesian and other traditional confirmation systems on the ground that it's reminiscent of neoclassical economics. And they, in principle, require you to be able to canvass all possibilities and make probability assignments and calculate on that basis, which, of course, is impossible. It stresses the limited horizons of imagination, horizons of conceptualization that we're always working under. So. One way to bring out the role or a role for heuristic appraisal, as I'm calling it, is look at the good old Reno problem. The Menon. You all know, but it's the conclusion is inquiry is not possible. Genuine inquiry is not possible. Learning is not possible. Therefore, the growth of knowledge is not possible. Because either you know the answer to your question in advance, or you do not. If you do know it in advance, you can inquire. You can inquire something you already know. And if you don't know, you wouldn't recognize the answer, even should you stumble on it accidentally. Now, we all believe that inquiry is possible, that we learned a great deal, and the standard answer is you go beyond between the horns here. Plato has in the mouth of Socrates, paraphrasing Meno's worry, expressing it in an all or nothing fashion, whereas we typically know at least a little bit. Our answers are somewhat constrained. There are hints, as we say in English, you're getting warmer, you're getting colder, and this is the role of heuristic appraisal, basically to detect and evaluate those kinds of hints. David Hume on induction has that nice phrase in which say, if Adam should come fresh into the world without any experiential knowledge at all, he would have no idea what would happen say in a given, what we would call a causal sequence. Say one billiard ball striking another, he would have no idea whether at it would not, whether the ball would go this way or that way, or turn into a pigeon and fly away, or suddenly explode in a flash, or anything else. I would have absolutely no reason. Well, recently, David Wolpert and William McReady have highly formalized these basic ideas. They cite Hume as a predecessor here. You can find other things in Wittgenstein and Carnap that are along the same parameters that sort of reflect the degree of connectedness of the universe and that sort of thing. But the qualitative thrust of the no free lunch theorems is that without having no domain knowledge at all, you have no idea whether any algorithm, any search procedure will work. You don't know whether there's a pattern there. It might be a Brownian motion, like Emiliano's first case in the last talk. In light of that knowledge, you're stuck with using extremely weak, sort of trial and error procedures. This, by the way, it's a somewhat controversial result. It's still under discussion. It's a series of results that are complex mathematically. But it also met quite a bit of resistance initially from the AI community, because some people in that community thought that there could be mathematical proofs that certain algorithms were just intrinsically more efficient than others in search. But the argument of Wolpert and McReady would be that in those cases they were at least implicitly assuming certain kinds of domain structures in advance, and that's if you average over all possible domains, then basically all the algorithms come out equal. So here's a kind of summary argument of, see if you're convinced that this goes through in the way that I think maybe it does. So Hume and the NFL theorems are basically correct. Insofar as a domain is new, we cannot know in advance whether any method will work or which method will work better than others. This is not just an abstract problem. I mean, as you well know, the sciences are applying their tools to new domains all the time. So I'm thinking back in the 60s, for example, when MacArthur and Wilson, Robert MacArthur and E.O. Wilson said, ecologists have been tramping around in the mud all these years, detecting patterns of butterfly wings and finding new species. But it's time for some mathematical theory in ecology. But it wasn't clear. I mean, ecological systems are so complex, it wasn't clear that we had any mathematics that would, suffice to provide useful models there. They came up with a model island biogeography that gained some foothold and so forth. But that's just an example of you just have to try things hypothetically at first using very weak methods. If you have little idea what the domain is going to be like, and proceed from there. Anyway, so I'm assuming that the NFL theorems and good old David Hume are basically correct. Then I think it follows there's no such thing as a general scientific method that concretely directs inquiry into new domains. That is a priori. The way Descartes and some of the early writers thought there was a scientific method that was a priori. I think the methodological claims, we do have methods, we have techniques, some very powerful ones, but those are conclusions of research, not prior to research. So there's no logic of discovery or logic of justification either. To 4, insofar as a domain is new, we can't know in advance whether any method wait a minute. Oh, this is not the latest version. This just repeats premise 1. Oh dear, this is not quite the latest version.
Maybe the PDF file, that's not the PDF file, that's the PowerPoint presentation. Maybe.
Yeah, that's okay. This will be close enough. I found it, So all genuinely new knowledge, even in normal research, is produced by a blind, undirected variation selection process. This is a view that Donald Campbell, and I mentioned yesterday, Dennett, Buck, and lots of other people, to some degree, have adopted. The blindness is partial here. It doesn't mean that in a domain where you actually know something that you just completely wild hypotheses. It's relative to domain and the type of problem that you're working on. So 7 in highly transformative domain areas, search methods are going to be weak, and we must resort to very general content-neutral heuristics such as hill climbing, or at a minimum, just a basic trial and error of ADSR. And choice of methods, including working hypotheses, is a scientific decision problems under uncertainty. Decisions made at transformative frontiers, by definition, have greater potential impact in the direction of science than normal decisions. And so our research heuristics, including any what I call heuristic appraisal, are going to be weak or rough in proportion to both the importance and the uncertainty of our decisions. Roughly. The more we need heuristic appraisal, the weaker it usually is. That's the trouble. That's the trade-off. Thus, we have little foresight or advanced control over the potentially deepest innovations. Here, I can't resist repeating that old pragmatic maxim. Every time I give a talk, it comes up somewhere. There are 2 ways to solve a problem. You can either get what you want, or you can want what you get. And roughly speaking, getting what you want is normal research. Wanting what you get is transformative, along the lines of writing very. So how do we identify potentially transformative research? What is a gatekeeper at some stage in the scientific community to do here? This is an older version.
You want a computer for here?
I've got my own computer there. Can I just plug it in? Yeah.
Maybe you have the last version. You need the PDF file, or?
No, I have. I know I have the correct file in there somewhere. But it's version.
This is enough.
Sorry about this. I think I still had it up.
Yeah.
The reason I didn't use it before, how do you make it, can you make it bigger on the screen?
Yes, like.
Ah, great.
It's different.
Yeah, so.
It's a conversation.
Okay.
Yeah.
Insofar as it's easy to recognize a line of research as potentially transformative, it's hard to recognize it as a serious contribution to the field being transformative threatens legitimacy. And insofar as it's easy to recognize as legitimate, it is normal science and not transformative. So it's a form of Kuhn's essential tension between tradition and innovation. And that, I think, creates a sort of policy problem, which I have a bit of personal experience with. To state the problem here, most funding agencies, especially in government, are structured to discourage at least strong attention to heuristic appraisal considerations, or to let them dominate any sort of confirmatory appraisal, because they're worried about, so much of our society today is concerned with sort of security issues, covering your ass, not wanting to be caught making a mistake of some kind. And so if you make short-term accounting decisions, you engage in risk avoidance and so forth. And government agencies especially are part of this. The question is, what could the alternative be? Well, let me, recently I was on an NSF panel, the United States National Science Foundation, for 3 years. And in our particular division and program, as the others, we had to somehow fit together these two sort of over or meta criteria. Besides just evaluating the competence of the grant proposal and so forth, we had to ask, is it transformative and does it have broader impacts? There are many contexts in which those two are completely compatible, I think. But the supervisor of the program I was involved in interpreted broader impacts to mean fairly rapid application to real world. She was an economist, and this ended up conflicting with, transformative things generally take quite a while. We're talking about often basic research here rather than things that have rapid application. And then take that together with the tremendous competition there is for limited funds. And there is a strong tendency, in fact, one almost has to do this to work efficiently, to use knockoffs, any flaw you can find in a proposal, you can use it to try to eliminate the proposal. So another thing that is now required by the government is data storage, data storage protocols. Because the data has to be available and secure, but also potentially in the future available to the wider public because it's government funding and so forth. And so you could see a proposal that really very good and an excellent proposal, but the person's kind of didn't take the data protocols seriously enough. A relatively trivial thing, it seems to me, and it would be grounds for dismissing the proposal. I mean, I think this is bad. But that's the way it goes. The European Commission, as far as I know, I was involved in a project down in Catania, the Mirrors project. Seems to have similar problems. The Lisbon goal was 2000 goal was to increase, if I got the numbers here correctly, science and technology investment from 1% to 3% of the PIB per year, and to achieve a competitive advantage in several fields by 2010. Of course, nobody was counting on the economic downturn. It would fell all of us up. But there was also a criterion which we can appreciate. We can sympathize with all of this, that they wanted the research to be not only innovative, but of clear social benefit from the get-go. Which means what? More government committees, more public input, more delays compared to the private sector. This means government-funded research is got even more moves to jump through. Canada recently announced, just a month or two ago, I think, that they were going to basically cut funding significantly to basic research in favor of so-called translational research. Is research that, when I say the biomedical fields, that you can immediately, fairly quickly make profits from, and so forth. So there are problems there. It's long been recognized that to get government grants, it helps if you can convince them that you already have the results, or enough results that's going to guarantee that the grant will produce the promised results. But as we well know, if it's going to be transformative to the frontier, there would be no such guarantee. Anyway, I've jotted down here some diagnostic features that I think help to explain the short-term accounting problem that we find these agencies, and several will be obviously quite familiar. But I think underlying some of them are bad philosophical models, and that's where we and other science studies people can hope to make a difference, and to policy eventually. We're going to have to get moving here. Okay, obviously the economic motives, we don't want to appear to be wasteful and so forth, but remember the early criticism of Darwin's theory, that it was very wasteful. Fish could produce millions of eggs, and only very few of them would live to reproduce and so forth. And so, if the failure rate is very high, the frontier research is such wasteful to some people because they think there's such a thing as the scientific method, which, if applied correctly, should prevent people from making mistakes of this kind. There's the political blame game and so forth. Let me just mention a couple of things and then pass on quickly to elsewhere. There is a strong commitment to intelligent design far beyond the religious debates that are going on, and this is where this BVSR stuff comes in. It's controversial, it's contested, of course, but I think if you look at any case of genuine human innovation, you'll find that a variation selection model applies there as well, but it's not intelligent design all the way down. If we had intelligent design all the way down, it wouldn't be innovative. So this is a point that just needs to keep being driven home, and so on. I'll have to skip the cartoons. Time is fleeting. There's something I like to call the end of history fallacy that I think discourages serious transformative research thinking. And that is, in mature sciences especially, we don't believe we have the final truth right now, but if you're a strong realist, you believe that you're somewhat near the truth. And so serious departures from the current view are to be taken with a great deal of suspicion. So it's the idea that we stand near the end of history in this regard. There's a kind of irony in that some of the two of the deepest historical thinkers of their time, Hegel and Marx, who just wrote the German deep history movement, both ended up in this view that huge transformations in the past, but of course we're not aware of those in the future because the future, our horizon is so short. It looks flat, like something like an extension of the present, as far as our current understanding goes. And so we can't imagine there are going to be such we can't specify such deep changes for the future. I think Kuhn was probably the first major philosopher of science to avoid this fallacy in large part by adopting his strongly non-teleological, non-representational view of scientific development. It was not working closer and closer to some final truth. He didn't even think, I think that idea made sense. A couple of comments along the way about scientific realism. Is there a strong form of scientific realism that avoids some version of this fallacy? I'm not sure there is, but I will leave that for another time. Various other tendencies that philosophers have, including the one that I mentioned briefly yesterday, if I'm not mistaken, Gillies, Carlo, and so forth, all commented on this idea of applying deductive logic or probabilistic systems, giving us supposedly a kind of ratchet. There's this sort of consequentialist idea that, well, even if the discovery context is trial and error, once something works, we can use probability or deductive logic or something to lock it into an accumulated increasing body of knowledge, and that there won't be any huge transformations necessary there. Okay, so what can be done? What role is there for heuristic appraisal? What role for general methodology? Here again is the line of reasoning. Hume and the NFL theorems, again, no general content-neutral scientific methodology. On the other hand, I'm committed to some version, at least at the present time, of this universal variation selection as the origin of all creative innovation. There seems to be an opposition here. In fact, Popper and Donald Campbell both saw two as, I think, support. For one, the BBSR approach seems to be the very antithesis of that, reducing things just to trial and error, which is the antithesis of method. But I'm interested in things like evolutionary computation, where using particularly computational abilities, we can scale up these kinds of searches so tremendously. It's very far from the kind of thinking that human beings do, and to this, it's very crude, it's very mechanistic to this point. It doesn't involve the kind of analogy and the rhetorical tropes that we humans can use quite fruitfully. But we now have thousands of papers in the various sciences and engineering each year using these genetic algorithms and so forth to solve problems in publishable ways and so forth. So I think in principle this can be scaled up to a kind of not precise method, because to apply it, it's like a very general mathematical tool like the calculus in some respects. To apply it to any particular case, you have to have some specific knowledge so that you can define your parameters and set up the algorithms appropriately to the domain in question, to the particular kinds of problem in question, and so forth. So I see this as providing us with a kind of general methodological shell that again has to be specified in any particular case. Well, what is the implication for policy? At the level of policy with these funding agencies and so forth, things are still pretty general. And I think we can apply these fairly general models of creativity and so forth at that level to improve our policy stance. So that's where I'm going with it. The question is, what is heuristic appraisal doing here? What role does it have? And I see it as having both a negative and a positive role. The negative role is just to sort of discount or eliminate or put aside models of intelligent design and that sort of thing that I think are corrupting too much of our policy thinking, maybe especially in government and so forth. On the positive side, we do have this shell idea that increasingly, as we get more computational resources in the future, more sophisticated software and so forth, I think we can expand our current capability in this area. Put it this way. We look back at Descartes and his idea of a general scientific method and so forth, and we think it sounds pretty silly, and it is by current lens. I mean, in the context of the time, it was very interesting and even brilliant. But if Descartes or Bacon or Newton could visit a modern, say, biological lab today, they would be incredibly impressed with the search techniques and so forth, and analytical techniques that we can use of all kinds, methodological techniques, but they're going to be very specific, very domain specific, very problem specific, and so forth. So again, the idea of a general a priori method doesn't work here. We have lots of kind of specific methods, and the stronger the domain knowledge is, the stronger our methods in principle can be, roughly speaking. In the longer paper, I put an old quote from fairly early in the AI game from Feigenbaum and also Alan Newell, that there's kind of an inverse relationship between the power of a search algorithm and the lack of domain knowledge. The more domain knowledge you have, the more powerful the algorithm can be. That's the idea. Well, at the end of the paper, and gosh, I am running out of time, is that right?
Yeah. 3-4 minutes.
How long?
3-4 minutes.
Oh, all right.
Yeah,
I'm skimming along very quickly.
You have time.
Well, at the end, I just throw out several models for consideration that which I won't have much time to talk about. But I mean, education systems. I mean, we're just looking at a level of high generality here, but applying these, philosophical critiques of certain pervasive models of originality and so forth. I think that we can actually get some leverage here. There's a considerable emphasis now among administrators, I think in Europe as well as in the States, on what's it called, cross-disciplinary and transdisciplinary research. That is, getting out of the old medieval model of having to do everything in terms of an academic discipline, a Fach, a kind of pigeonhole in the German sense. But unfortunately, university accounting systems, they're retarded. They don't know quite how to handle this, to reward people or not for, in terms of all kinds of things, credit, salary, and so forth. So they're very basic things like that. The Silicon Valley model is a model in which the hierarchical, top-down command and control structure of old companies where, say, all the innovation was stuck in a research and development compartment and everybody else is supposed to shut up, is sort of disappearing in terms of a much flatter administrative structure, where people are even encouraged or at least allowed to cross company lines. They meet in bars and things, and they raise problems for each other. Okay, I'm working on this problem, what do you suggest? Maybe working for a competing firm or something. And this sort of informal sort of organization, DARPA uses this model as well, the Defense Advanced Projects Agencies. Not a perfect model for basic scientific research because it's focused on specific applications, but it does have some interest for us, I think, and it is a government model that's much more streamlined than NSF, NEH, and talking about U.S. organizations that do the same kinds of things here in Europe. A mix of government, university, and private enterprise people, and one thing they do, they have a fairly short turnaround, but they do a lot of informal mixing. They get together in Washington for a day of meetings, but at 5 o'clock then they rent a boat on the Potomac, and so everybody can mix over drinks and sandwiches and so forth. Yeah, great out there. We should extend our breaks instead of listening to people like me. And so that kind of works. Just one or two things I'd like to mention. The shale oil scenario planning model, I think, is I already mentioned that. Mentioned scenario planning briefly. I find that interesting in that it's a way that you can be partially communistic. In that shale oil did this with Russian oil and gas reserves back in the old days of the Iron Curtain and so forth. They tried to formulate, say, 3 or 4 future world scenarios that, should they happen, they would be in position to take advantage of. And one of the scenarios was that somehow companies in the West would get access to Soviet resources. And then they had a little contingent of people sort of following. So as Gorbachev, this economist, gradually rose in the party and so forth. It's been very interesting. So they were well poised when the Soviet Union fell. Now the idea here is they're not assigning probabilities; it's possibilities, but it's iffy. So you're not undermining the status quo either. So if you're doing this in a scientific context, you needn't be regarded as directly challenging the current paradigm or convention, but just here would be an interesting line of research to possibly investigate, given the huge payoffs, the huge utilities that there could be. So again, it's not an application to the sciences that I've explored in any detail, but it strikes me as intriguing as a sort of non-probabilistic, maybe not even plausible scenario, because they would try to choose 3 or 4 scenarios which were widely enough scattered that the group taken together would sort of keep people on their toes, and they wouldn't fall into a kind of a rut of conventional thinking about what's going on. So various other kinds of models. Let me just mention very briefly. Drucker's a summary of 4 kinds of company improvements. The 4th one, the most innovative, improvement via innovation, to create the different tomorrow that makes obsolete and to a large extent replaces even the most successful products of the day in any organization. Now, if you're in the sciences and you have a sort of a deep historical view, you've got to think that 50 years from now, 100 years from now, 500 years from now, our most mature sciences are going to look radically different than they do now. Physics, evolutionary biology may be undergoing that medieval revolution right now. We don't really know, it's too early to say, and so forth. If you take that kind of attitude, you're not going to be quite so closely stuck on current conventional thinking. Now, I'm not trying to be a mad, crazy radical here and just say we should just go off in all directions. But we should be more open to heuristic, promising possibilities that that depart in some regard from conventional thinking that might have very significant payoffs for us. I mean, one company that does this, and I think philosophers can learn something from looking at business, looking at not just economics, but looking at practical business arrangements and so forth too. Thinking about the Silicon Valley architectural arrangements, so that people have a chance of recombining their ideas in various ways. But the 3M company in Minneapolis, St. Paul, since 1948 has allocated a certain amount of people's normal work time, all the people, I guess, in the company, not just in the R&D division, to think up new products or new ways of becoming more efficient or whatever. And with the idea that, I forget what the exact figure is, that in any given year, something like 30% of their sales will be from products just introduced within the last 5 years. So there's this real pressure to innovate in this kind of way. And I think some of that could pay off in scientific decision making. Interesting sidelight, recently there was a change of CEOs a couple, 3 years ago at 3M. And this person installed one of those rigorous Six Sigma management systems of absolute quality control, claiming that the old system was wasteful. There was too much slacking. And as a result, it seems like innovation has gone down as a result. You need slack, you need room for failure, you need room for risk taking and so forth to get these things going. Well, just my final little barrage here. I think if you take heuristic appraisal more seriously, and that is given at least a little bit more weight in these decision-making processes, both at the individual scientist or the the research team making a decision about a problem to work on, and the grant to write, grants committee members making decisions on which grants are interesting, promising, and so forth, all the way up the line. I think if you do that, you'll find that there are some factors that are really relevant in the long run to the growth of knowledge problem, only they're not things that we could specify in advance, and so they tend to be ignored by people like, by us, philosophers. The kinds of factors involved are going to be the kinds of things that people traditionally regarded as external ones of no interest to the epistemic enterprise. And yet, it seems to me the infrastructure there is terribly important to the flourishing enterprise of that sort. So that was, well, as usual, I threw in far too much for the limited time. I hope you can get some sense out of it. But it does seem to me, besides engaging in highly specialized work in the biological sciences, the Department of Neuroscience, that many philosophers are doing these days, and that's great. But there's also, we can do more in the policy area by helping to develop and promote these kinds of models. And drawing attention to the fact confirmation theory has not been successful. It's not been successful. I mean, in the paper I quote von Frosten, who's not exactly a slouch when it comes to these things. Dismissing a traditional probabilistic confirmation theory is something of a running joke. And yet it's gotten 98% of the attention from people working in this area. Admittedly, heuristic appraisal is an extremely messy subject. I wish more people would work on it. It's not likely to give way to a neat calculus, probability calculus, or Bayesian approaches, or anything like that. So it's not attractive to hard technical people of that sort. It seems to be in the overall research domain. It's important. So I always recommend it.
Hello. I want to make use of the chairman's privilege to ask the first question, but I thought, as no one can hear me, I'd better use this device. Well, one thing that interested me a lot is that there was a debate or a discussion in